The goal of this video is to find the Laplace transform of the first derivative of y. And keep in mind again that y is going to be both exponential order and it's going to be piecewise smooth. And again, that means that the function does not grow too fast and the function has left and right limits that are finite. All right, so we're going to go to that definition of the Laplace transform, which is once again the integral from 0 to infinity of y prime times e to the negative st dt. And when we look at this integral, we know it's a product. So again, a good strategy would be integration by parts. But we have to be very strategic about it because we have to make sure that we have something that we can easily integrate and differentiate. And you'll notice that you want to actually let the y prime dt be the dv part of this so we can integrate it, because we don't want to take another derivative and introduce a second derivative and make things more complicated. So we're going to go ahead and let our u be our e to the negative st, and again the dv will be y prime dt. So upon integrating, we're going to have a du is equal to negative s times e to the negative st. And then we're going to have the v, when we integrate it, is just y of t. So now we go back into our parts, and we're going to have u times v. So that's going to be y of t times the e to the negative st from 0 to infinity, minus the integral from 0 to infinity of v, which is y of t, times our du, which is negative s e to negative st, and again dt. So we're going to first take a look at evaluating this limit. This is the limit as t goes to infinity of y of t e to negative st from 0 to t. And then here, with our double subtraction, we're going to have plus. We have a constant s, which does not depend on t, that we can factor out times the integral from 0 to infinity of y of t times e to negative st dt. So for our first term, we're going to have the limit as t goes to infinity of y of capital T times e to negative st minus, using a fundamental theorem of calculus, y of 0 e to the negative s times 0. And then we're going to have plus s times the integral from 0 to infinity of y of t e to the negative st dt. Now, in this first term, we notice that we're going to want to have some of these terms go to 0. And we said before that y of t is of exponential order. So that exponential order of the y of t and the e to the negative st is going to have a limit going to 0 because of the fact that the y of t is going to grow smaller than the e to the negative st decays. So again, this limit is going to be 0 because y of t is of exponential order. The next term, well, of course, e to the 0 is just equal to 1. And then back here, rather than trying to calculate this again, you should recognize that this is nothing more than the definition of the Laplace transform with y in place. So this is nothing more than just our typical big Y of s. So when we go ahead now and look at our final result, we've got s times big Y of s, the Laplace transform of y, minus y of 0. And that is the Laplace transform of y prime.